qué alegría estar otra vez con un nuevo streaming. Estamos teóricamente a 23 minutos de que comience Rocket Lab. Lanzamiento con el mejor sonido del mundo, en mi opinión. También tenemos una misión secreta. Yo estimo que a los 9 minutos de misión se va a terminar el streaming. Vamos a poner un poquito de música. Y paso a saludar. Va mejorando la voz, ¿no? Nikon a full, primer miembro VIP que escribe en el chat. Rosana Chávez, de México, Ángel Mandujá nos saludaba hoy. Desde muy temprano están acá. Demoraron por mal tiempo, por vientos fuertes en altura. Paso a ASMR, modo ASMR. ¿Qué es lo que pasa con el tema del viento en altura? Si el viento en altura cambia bruscamente y está muy fuerte, cuando pasa el cohete a través, se rompe, se parte. Máximo Q supera su resistencia estructural máxima. Ese es el peligro de lanzar con mucho viento en altura. Como saben, el viento con globos meteorológicos es fácil, lo sueltan, sube, tiene un transmisor, va diciendo en su posición GPS y calculan cómo está el viento. Rodrigo Pérez saludaba de Maldonado, que se iba a dormir. Buen jazz para madrugar. Bueno, dormí una hora. Luego los mensajes, a ver qué hay. Ando router para Madrid, dice Héctor González. No sé dónde estás. De trabajar no puedo quedarme like, después lo veo diferido, dice David Amengol. Muchas gracias, David, por haber estado acá pasado. Gracias. Uy, buenas noches, dice Rodolfo Gallego. El Ángel Teti. El Ángel Teti. Gracias por esa membresía VIP, Miguel, gracias. Se te fue el audio. Se me fue el audio. No, el audio está. No sale mi voz ahí. Increíble fondo. Sí. Yo digo, ¿cómo no iba a poner este fondo? ¿Cómo no iba a poner esto? Karina, es increíble este fondo, la verdad que sí. Te escucho bien, sí. No me asustes, Miguel. Después yo ando tocando cosas y es al revés, le amarro. Leonardo de Rocket dice, Dani, ¿cómo estás? Después yo ando tocando cosas, Miguel, porque me dicen, le amarro. Leonardo de Rocket decía, hola Daniel, ¿cómo estás? De tiempo te puedo ver ando por los últimos 2 ciclos de la universidad. Ya full, pero esté bien. Qué genial, vamos arriba. Fuerza, Leonardo. ¿Qué estás estudiando, por cierto? Contanos. Gracias, Andrea. Yo la disfruto muchísimo también. Canta el jazz. Lo saqué, perdón. Genial, ingeniería ambiental y especializándose en los sistemas de información geográfica para trabajar. Qué bueno, Leonardo, me encanta, ingeniería ambiental, pero también con información geográfica. imágenes satelitales y más cositas. Hay que estar al día y hablar. Date otro café. No, si ya empieza Rocket Lab en cualquier momento. 1313. 1313. 1309. Falta poquito. Disfrutemos un poco los blues. Jazz. Y empieza. Vamos a poner algo viejo de Rocket Lab. Es una repetición de Capstone, el lanzamiento nocturno, de hace muy poquito, cuando mandaron la nave esa a orbitar la Luna, que en noviembre recién queda insertada en órbita.
Nine, 8, 7, 6, 5, 4, 3, 2, 1. And lift off. Space VB discharge now.
Stage 1.
Seven, 6, 5, 4, 3, 2, 1. And lift off. Space VB discharge now.
Stage 1 propulsion is nominal.
Entering burnout detect mode.
Impresionante. Impresionante, la verdad. Estamos a 8 minutos y no deja de sorprenderme esta gente, con no solo con la calidad de imagen, sino también con el sonido, ese lejos. Si no sonó bien la primera vez, error mío.
just really in a standard all sky. Just look at, let's be fair. Let's go to a really deep, clear thread and unwise. Nothing like what you see on this incredible image. Let's just zoom in. Take a look around. Incredible detail. And then zoom way out. Give you some picture of what a piece of the sky that really is. But my, what an awesome, awesome picture. His telescope image released first. On July 11th.
Nicaragua, 0005 PM, decía ella que estamos. Me encantó como dicen en Brasil, el bate papo. O sea, la charla. Gracias. Si el web llega a captar el globo que se me escapó de mi cumpleaños. Sector González. Segunda vez que lo escribí ese chiste viejo, ¿no? Salud de España. Dice Juan, buenos días. 809 de España. Rocket Lab comienza. Vamos, Rocket Lab, Me queda una cámara por poner acá. mi gente bella, dice. Querido. Yo encantado, dice César. Gracias a ti te deseo pronta recuperación. Muchísimas gracias. Los cientos de mensajes que llegan por día. El canal, en los distintos videos. Todos positivos, así. No solo canta, sino que uno levanta el ánimo, le da más ganas. Saludos a tus perrijos, Daniel. Saludos a tus perrijos, dice María López. Si lo llegan a ver, se mueren. Recién pasé. Hay uno que se tiró en uno de los sillones y debe haber pasado uno de mis hijos y lo tapó. No puedo creerlo. Qué divino tebular. Esto es espectacular, la península de Magia en Nueva Zelanda. En el medio del mar. Bueno, en helicóptero, ¿lo vieron? Voy a parar. Voy a detener esto. Mire este sitio acá. Ahora lo vemos desde atrás, desde el otro lado. Ahí se veía. Voy a ir deteniéndolo justamente para... Sale el hangar, miren el helicóptero. En esto llegan la gente que trabaja allí. Y mostrarles eso. Por eso lo detuve.
Back-to-back missions for the United States National Reconnaissance Office. You're looking at a live view of our Electron rocket vertical on the pad for our Wise One Looks Ahead mission at Launch Complex 1 as we approach T-minus 17 minutes in the countdown to today's launch.
7
My name is
minutos para
Felicity
las...
Powell and I'm here with my colleague Katie Gwozdecki, and we'll be with you throughout today's live broadcast from Rocket Lab's Mission Control Center in Auckland, New Zealand.
That's right. Liftoff today is scheduled for 18:30 local time or 6:30
Faltan los
UTC.
nombres ahí abajo.
Launch operations are proceeding well as we approach T0. However, we're monitoring some strong upper-level winds as we move through the count. We'll keep an ear out for weather updates as we get
Siguen
closer to
monitorizando
launch.
los
We
vientos
can
en altura.
expect an update on this
Dice
in
que
the go, no
por ahora dan verde. Y falta el go no go.
Dedicated Electron launch is the National Reconnaissance Office, or the NRO. Headquartered in Chantilly, Virginia, the NRO develops and operates unique and innovative satellites to meet national security needs. Since 1961, NRO has pushed the envelope of U.S. space-based intelligence collection as it develops, acquires, launches, and operates the world's most capable intelligence satellites. Here's more about the National Reconnaissance Office.
For 60 years, we have been making the intelligence that keeps America safe possible. We are the leader in developing.
Oficina NAcional de Reconocimiento de los Estados Unidos. Le bajé el volumen porque nos van a bromar con el copyright. No es la primera vez que utilizan música. Ya nos pasó con la presidencia de Estados Unidos. Cuando Biden presentó las cosas, pusieron música con copyright y nos hicieron reclamo. Yo no puedo creerlo. Por favor. Qué divino que es el Atlas. Qué divino.
We're honored to be partnering with the NRO and excited to be launching for them once again. Today's NROL-162 payload will be used by the NRO to help provide national decision makers and intelligence analysts with timely information that supports their interests and humanitarian efforts across the world. We have flown missions to space for the NRO twice before. The first was the Birds of a Feather mission, launched in January 2020.
Ya dos veces antes. En enero del 2020, ahí está mostrando.
For the NROL-151 payload, and also had some very early rocket reusability testing, where we successfully completed a guided re-entry of Electron through Earth's atmosphere after launch. It's amazing to think that since that mission launched just over 2 years ago, we've progressed our
Es genial.
first reusable small rocket, to the point that we are now snatching Electron out of the sky with our own rocket-catching helicopter.
Shortly after the Birds of a Feather mission, we launched 3 NRO payloads, on our second mission under the NRO's Rapid Acquisition of a Small Rocket contract, or RASR contract, collectively called RASR-2. On board the Don't Stop Me Now mission were 3 satellites, designed, built, and operated by the NRO, but in this instance they flew on a commercial rideshare mission, alongside small sats by NASA and the University of New South Wales Canberra Space, together with the Australian Air Force. Today's mission will be
Están
the
contando
third
justamente
NRO
la primera y segunda misión y ahora vienen con esta.
which supports the NRO to launch small satellites commercially through a streamlined approach.
Ya en el segundo,
To space, we come up with a name that represents
llevaron carga de la NASA, también fue compartido.
and a unique mission patch to match. For NROL-162, the name Wise One Looks Ahead is a translation of the NRO's Latin catchphrase for this mission, Sapiens Qui Prospicit. For the NRO, this represents their work with present and future partners in space. In particular, it's a shout out to their partnership with the Australian Department of Defence, as the NRO commits to enhancing.
Este lanzamiento también es parte de un arreglo que tienen con el Departamento de Defensa de Australia, que lo hicieron nuevo ahora en NRO,
Used on this patch to further symbolize
la Oficina Nacional de Reconocimiento de los Estados Unidos.
The NRO has also come up with its own patch for this mission, one which instead features an Australian frilled neck lizard to represent the small and agile nature of the payload being launched on today's mission.
A quick check-in on the countdown clock and we can see we're at T-minus 12 minutes to liftoff. Soon our launch director Joseph Carpico will check in with each mission operator for a quick green or red on whether to proceed with the remainder of the count.
11
This
minutos
is called the
ahora.
go, no-go poll for launch, and it will be coming up shortly. Let's listen in.
All operators, this is the LD on mission, proceeding with the go, no-go sequence. Stage.
Stage is go.
Avionics.
Avionics is go.
Vcon.
Vcon is go.
T1.
T1 is go.
GC.
GC is go for launch.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
Mit is go.
GNC.
GNC is go.
MM.
MM is go.
SVMD.
MD is go.
LD SUP.
LD sup is go.
That completes the go, no-go sequence. We are T-minus 11 minutes, 16 seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
And with that, our launch director has confirmed
A
that we
partir de los 10 minutos comienza la secuencia de lanzamiento.
today for 18:30 local time or 06:30 UTC. For our Eastern Time Zone viewers, that's 02:30 in the morning, and in Pacific Time, liftoff is targeted for 23:30.
Agility and quick access to space are increasingly important to the way the world responds to conflicts and crises. Using the vantage
Lo de crisis, dice, llegar rápido es eso, y este es un contrato rápido con la oficina de la eso se refiere.
movements, weather patterns, and economic activity. During humanitarian crises, satellite data can reveal troop movements and refugee streams that help governments, first responders, and aid organizations focus on where they're needed the most. The faster satellites can be placed in space, the more capable space infrastructure will be. But to do that, modern nations need responsive rockets, responsive launch pads, and
Está hablando de lo que están haciendo ahora, de algo que está haciendo Rocket Lab justamente, que es dar rápida respuesta a los gobiernos cuando necesitan un lanzamiento. Es algo que hoy no tienen. Hoy si un gobierno quiere lanzar algo rápido es difícil, porque no hay cohetes prontos, porque no hay reusabilidad, porque no hay disponibilidad de vehículos.
And faster build compared to much larger or traditional rockets. With 147 satellites delivered to
María López, Júpiter, qué genial. ¿Con qué ves? ¿Con qué está viendo Júpiter? ¿Qué equipo tenés?
rocket, our launch cadence and responsiveness will only
Hoy no duermo. Yo vengo por esa también.
Responsive satellites needing responsive rocket, and
Me
the
retaron.
third piece of the puzzle is a responsive launch range to fly them from.
Me retaron porque vengo durmiendo 3 horas por día. Dijo, tenés que descansar. Es parte de la curación. Lo voy a hacer.
Our only priority is Electron.
Digo, lo voy a hacer y termino acá y me pongo en el simulador.
Range control, rocket integration hangar, payload clean rooms, and 120 opportunities to fly every year.
Es hermoso este cohete. Vamos a ver un poquito el cohete.
Just last week, we wrapped up our first ever mission to the moon. And now here we are, back at the pad. Ready to watch Electron lift off at Launch Complex 1 for the second time in 15 days. The Capstone mission is the first step in support of NASA's Artemis program to return humans to the moon. And our role of this mission not only included a dedicated launch on Electron, but also featured in-space assistance with the debut of our Lunar Photon spacecraft to help Capstone reach the moon.
The first phase of the mission on Electron saw Capstone leave the launch pad at Launch Complex 1 on June 28th during a flawless nighttime launch. Our rocket made it through the usual launch milestones before Capstone was dropped off to a very low Earth orbit of just 165 kilometers. In Phase 2, that's when our Lunar Photon spacecraft came alive and took over the mission. Over the next 6 days, Lunar Photon slowly and steadily raised Capstone higher above Earth in increasingly elliptical passes using our own Hypercurie engine, before finally we shot Photon and Capstone free of Earth's gravitational pull and on a path to the moon with a super-powered engine burn. Capstone was then detached from Photon, marking the successful end of Rocket Lab's involvement in the mission, as management of the CubeSat's solo journey to the moon was handed over to NASA and Advanced Space.
The Capstone mission marked the beginning of humanity's return to the moon through NASA's Artemis program, and we're incredibly proud to have played a key role in that. Our team dedicated 2 years of their lives to this mission, working on the design of our Lunar Photon spacecraft, the development of our first deep space engine Hypercurie, setting the mission trajectories to deliver Capstone on its lunar path, and so much more. Capstone was by far our most complex mission to date as we pushed Electron and Photon to their limits. But now, having proven what we can do with our groundbreaking technology and small satellite missions beyond Earth, we're already looking forward to more interplanetary missions, including our upcoming journeys to Venus and Mars as early as next year.
Now, back to the mission at hand, preparation for today's launch began several hours ago, as the vehicle was rolled out from the hangar to its launch position at the end of the runway. Here, the strongback lifts Electron to its vertical position on the pad, a process that only takes a few minutes. We begin LOX fill, fueling Electron with super-chilled liquid oxygen at around 2 hours prior to scheduled liftoff. We do this as late as possible to keep the LOX as cold as possible.
In the hour before T0, mission control operators are continually checking the vehicle systems are healthy and that the conditions are favorable for liftoff. With 18 minutes left on the clock, the launch director runs the go-no-go poll with launch operators to confirm Electron is ready for flight. At T-minus 2 minutes, Electron transitions to autonomous flight control and takes over the launch countdown. The famous countdown is conducted by the launch director from T-minus 10 seconds, and with 3 seconds to 0, Electron's 9 Rutherford engines ignite and lift the vehicle off the pad.
Liftoff itself is a milestone, but there are many other checkpoints in Electron's journey between preparations and mission success. First, Electron must pass through max Q, maximum aerodynamic pressure, where the point where the forces acting on the rocket in flight are at their maximum strength. Mission control will confirm when Electron has passed max Q. The next checkpoint is main engine cutoff, when the 9 Rutherford engines on Electron's first stage power down to decelerate the vehicle a few moments before the first stage separates from the vehicle. From here, the single space-optimized Rutherford engine on the second stage fires up to push the second stage and kick stage with payload attached the rest of the way to pass the Kármán line into space. At this point, the payload fairing on Electron's nose will separate and fall away, no longer needed to protect the satellite from Earth's atmosphere.
Once Electron has reached an altitude close to where the satellite needs to be deployed, the second stage of the vehicle separates from the third stage, called the kick stage. This kick stage is propelled by a much smaller engine called Curie, which can then propel the satellite to its precise destination, sometimes within just meters of its intended orbital location. As soon as the kick stage has deposited the satellite to where it needs to be, we can declare the mission a success and congratulate our customers on finding their new place in space, while Rocket Lab adds another successful mission to our heritage.
And so, with just 3 minutes left before liftoff, let's switch to mission control to hear the final countdown before launch.
Cuenta final.
This is the LD on mission. From now on, there should be no red flags on your critical LCCs. Beacon LD on mission.
LD Beacon.
Yes, sir. Please confirm all expected flight computer as goes are green.
Confirmed, all as goes are green.
And Beacon lock auto sequence and confirm.
Confirmed, auto sequence is locked.
Cuenta final, ¿eh?
LD on mission. We are go for auto sequence.
Auriculares.
T-minus 2 minutes. LD is go for launch.
Volumen al máximo o avisarle a los vecinos. Es el momento.
LDGC on mission.
Go ahead, GC.
ECS disabled. Pad auto sequence is armed.
Bueno,
Pad ready.
tenemos un cohete Electron
GC.
de Nueva Zelanda con carga secreta para la Oficina de Reconocimiento de los Estados Unidos. 2 minutos del lanzamiento. Rocket Lab USA. Javi, muchas gracias Javi por esa donación.
Vehicle is on internal power. AFDS is green and enabled for flight.
El vehículo está con potencia interna, o sea, con sus baterías internas. El power, me encanta como lo dicen en australiana. No, neozelandés, perdón.
Lock load complete. Lock system in recirc. All helium anti-gathering disabled.
Stage 1, stage 2, press for flight.
High flow engine purge enabled. Water deluge activated.
T-minus 20 seconds and counting.
Segundos. 15. Yes.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff.
Stage 1 propulsion is nominal.
High voltage battery discharge, nominal.
Our 28th Electron launch vehicle has successfully lifted off the pad and is
nominal.
on its way to space.
Todo nominal.
Before it gets there, it has a number of critical milestones to pass through. The first of which
Recuerden,
is called
lo próximo es
Max
máximo
Q.
Q.
Max
Máximo
Q is
Q.
the first test in Electron's journey, where it experiences maximum aerodynamic pressure, or where the forces on the
Para
rocket
gente
are
nueva,
at
que
their
es Max U, es la máxima resistencia aerodinámica del cohete, es la parte más crítica de esto.
Past Max Q.
Bien, pasó Max Q.
There's the call. Mission Control has reported Electron has successfully passed through Max Q, its first milestone after lifting off from the east coast of New Zealand. The 9 Rutherford engine on Electron's first stage are performing well, and we're ready for the next series of milestones in the launch process.
Up next is main engine cutoff, known as MECO, which immediately precedes stage 1 separation. MECO allows the vehicle to decelerate slightly before the first...
Para la gente nueva, ¿qué es lo que pasa ahora? Estas llamas se están abriendo porque se están expandiendo. Estamos mirando del cohete hacia abajo. Ya que el cohete sube, miren la altitud acá arriba, 37 kilómetros. Va subiendo. La atmósfera queda menos densa. Tiene teóricamente menos donde agarrarse, donde empujar esas llamas. Entonces se abren, se expanden más. Empiezan a ser menos eficientes esos motores Rutherford. Se nota clarito. Entonces ahora los apagan, se separan las etapas, se separan las cofias y luego enciende la otra etapa, la segunda etapa. Ahí fue. Mico.
Mico, confirm.
Mico porque main engine cutoff. Separación con éxito y ahí enciende la segunda etapa.
And stage 2 mission.
You can see on your screen that
La segunda etapa está optimizada para estar en el espacio.
the single space-optimized Rutherford engine on Electron's second stage is glowing red as the nozzle radiates heat from the exhaust. Because the vehicle has now cleared the majority of Earth's atmosphere, we can get rid of the payload fairing to shed some extra weight. We should see that on our screens shortly.
Fairing jettison succeeded.
Stage 2 propulsion is
And there it
nominal.
is. You can hear the payload fairing tumbling away on your screens now. The NRO payload is now exposed to space in preparation for payload deployment later in the mission.
This fairing will burn up as it re-enters the atmosphere, while the second stage continues on.
Bueno, esta etapa, una vez
If you're
que
just joining us, we've had a successful start to Electron's...
una vez que deja su carga, esta etapa, ¿qué es lo que pasa? Invierte, o sea, pones motor hacia adelante, enciende para desacelerar y regresa quemándose, se quema.
stage with the payload attached the rest of the way into space. At about 10 minutes into the mission, the kick stage will separate and its Curie engine will precisely deliver the payload to its intended orbit.
Luego hay una etapa siguiente que es la Curie, que es similar a la que llevó Capstone a la Luna y es la que termina de colocar la carga. Escuchen el rum.
The shape of an orbit is important. In fact, the entire Capstone mission we launched last month was to test the efficiency of the near rectilinear halo orbit, or NRHO, around the Moon. In most Electron missions, our second stage delivers the payload to an elliptical orbit. We then use the Curie engine on the kick stage to circularize that orbit, basically make it circular, to deliver the payload to its new home in space. Quick update, Mission Control is reporting the vehicle is healthy and making good progress onward to deliver its NRO payload.
If you were ever curious, when Electron takes off, it weighs 13 tons, but 90% of that is actually fuel. Electron is so efficient that
13 toneladas le pego,
it only weighs
pero el
1.2
90% es
To
combustible.
optimize our weight, we also use a carbon composite shell that in some places is less than 2 millimeters thick. That's thinner than your windows at home. Carbon fiber materials are strong enough to manage the environmental stress from launch while being lighter weight than traditional materials, so we can bring even more payload mass to space for the same fuel.
Thank you.
200 seconds to go.
Electron is one of a kind.
Lo próximo que pasa ahora, este cohete no, las turbobombas no son como en todos los demás cohetes que se usan combustible. Ellos usan baterías eléctricas. Es el único. Creo que Astra está haciendo lo mismo. Lo que hacen ahora, y está marcado acá, es Battery Jettison. Cambian las baterías o usan la de reserva, o sea, la segunda. Y esa por el peso, que es mucho, la tiran al espacio, la desechan. O sea, cae a la atmósfera, cae al planeta.
Hard swap successful. Battery jettison confirmed.
Es importantísimo esto.
There you have it. It happens quick, so hopefully you caught a glimpse as those batteries were ejected from the vehicle.
Dice que se vio, a ver si se ve. Vamos para atrás. Acá está. Esta es la batería. Acá se ve clarísimo. Pase para atrás. Estamos repitiendo. Estén atentos.
Hard swap successful.
Ahí se fue.
Battery jettison confirmed.
The vehicle is continuing well onto orbit, and we're making good progress in our journey to payload deployment. Before, you may have heard Katie talking about how much of the mass of a space rocket is propellant or fuel. But what happens as we use it up? Electron uses most of that fuel in just 8 minutes, which creates a lot of empty space inside the rocket. We actually use helium gas to maintain equilibrium and pressure between the inside and outside of the
Están
rocket.
contando un poquito lo de la mecánica, cómo es. En los 8 minutos utilizan el 90% del combustible. Y como queda vacío el tanque, lo que hacen es rellenarlo con helio. Para seguir
The views
teniendo
on
presión.
screen show the glowing red nozzle of our Stage 2 engine. The Rutherford engine on our first stage inspired this second stage, but they operate in fundamentally different environments. Rutherford nozzles are designed with a focus on corrosion resistance and environmental robustness, as it must survive the super high temperatures and pressures during launch. Our second stage engines are designed for space propulsion, so we instead focus on making sure it can cool itself off as it gets extremely hot without convection in the vacuum of space. You can see this
Leonardo,
happen
para quien decía lanzamiento perfecto, Gamba no defrauda el sonido,
3D
no,
printed in our
nunca.
Rocket Lab factory
Rocket Lab
in
es
California,
increíble.
allowing our engineers to easily make small tweaks to make our engines more and more efficient after each flight.
Parece que estamos adentro de la Enterprise.
Entered burnout detect mode.
Stage 2 propulsion.
Our next big milestone for Electron is second engine cutoff, or SECO. Just like MECO,
Se viene el segundo corte de motor.
shut off ahead of the
Seco
final
en inglés,
separation of the second
por
stage
decirlo en
from the
inglés.
last or third
Y luego se separan las etapas. Otra vez. Pero ahí queda la última.
and on the kick stage will carry the payload to
Ellos le
its
llaman
last
kick
destination.
stage, o sea, etapa de pateo,
For
como
this
que le dan una
mission,
patada.
we'll wave goodbye to the kick stage and to you after SECO and second stage separation.
No parece muy estable la combustión, dice Treno. Dice que no, pero funciona, ¿no? Bueno, corte.
Perfect transfer orbit.
Bueno, buena órbita de transferencia.
Stage 3 separation confirmed.
We've received confirmation from Mission Control that Electron's second stage engine has shut down and the kick stage has successfully separated, now en route to deliver the payload to its destination in orbit. Over the next hour or so, the kick stage will make its way to the correct location in low Earth orbit ahead of payload deployment. Thank you to the NRO for choosing to fly on Electron launch. Our first successful interplanetary mission to our manifest after Capstone was successfully inserted into its ballistic lunar trajectory last week We are actively recruiting the next generation of space talent as we grow and
Están pidiendo gente que se sume, están reclutando a la gente.
in particular, we're hiring mission operators for our Mission Control Center. If you want to be at the controls of some of the most exciting new ventures in commercial space exploration as humanity returns to the moon, Mars, and beyond, apply today by visiting rocketlabusa.com.
Están reclutando gente.
Education, we have
Misión
plenty of
control.
opportunities for you to get involved
Sigue
with the space
creciendo.
industry. You plot your path to the stars. For students,
Vamos a repetirlo ya ahora. Pero la gente que está viendo el corto, les agradezco enormemente el apoyo. Nos vemos en la próxima.
informed and involved in Rocket Lab's mission to make space accessible for all.
Y bueno, con el
Of course,
resto de ustedes seguimos, vamos a repetirlo.
us on social media to stay up to date with everything we do at Rocket Lab. It's been great to have you share these moments with us. I'm Felicity Powell.
And I'm Katie Gwazdecki. This is Rocket Lab Mission Control, signing off.
T-minus 20 seconds and counting.
Vamos a hacer una repetición.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff.
Stage 1 propulsion is nominal.
High voltage battery discharge, nominal.
Our 28th Electron launch vehicle has successfully lifted off the pad and is on its way to space. Before it gets there, it has a number of critical milestones to pass through, the first of which is called Max Q. Max Q is the first test in Electron's journey, where it experiences maximum aerodynamic pressure, or where the forces on the rocket are at their peak.
Impresionante, impresionante esto, la verdad. Ese micrófono gordo es brutal.
Past Max Q.
Nice.
Lástima que la voz es tan fuerte.
There's the call. Mission Control has reported Electron has successfully passed through Max Q, its first milestone after lifting off from the east coast of New Zealand. The 9 Rutherford engines on Electron's first stage are performing well, and we're ready for the next series of milestones in the launch process.
Up next is main engine cutoff.
Me pasé hasta decirle que muchísimas gracias. Treno dice, sí, cuídate, es importante. Estoy en eso, quédense tranquilos. Ahora, en cuanto me dé un poquito de sueño voy a dormir. Les actualizo algo. Hoy estuve en el médico. Estoy impresionantemente agradecido de cómo me atienden. No están todavía los resultados de los análisis. Ayer llegó la muestra Washington, en los Estados Unidos, para hacer un análisis nuclear. ¿Se dan cuenta de lo que estamos hablando? Mi caso es rarísimo. Es el primero en mi país. Y como analizarlo, mandaron la muestra a Estados Unidos a un laboratorio y están haciendo un análisis nuclear. El tratamiento que me van a hacer va a ser un análisis bionuclear dirigido específicamente a eso. Tengo suerte, la verdad. Me considero, dentro de todo, afortunado. Afortunado por esto también, porque están acá. Porque son las 3:45 de la mañana. 3:45. Están todos acá. Un abrazo enorme. Coti, por favor, transpórtame. Gracias por todo.